Hello everyone. In this lecture, I'm going to try to give a brief introduction regarding the HG5000 software, how you can draw a ladder diagram in this software in order to program a PLC board. Now, this particular example of traffic light sequence control was discussed during your theory class, how these control sequences can be represented in the ladder diagram that was discussed. So the ports that we considered for the inputs and the outputs are shown in this slide, and considering these input output ports, we discussed a ladder logic program that is shown in this particular slide. So how this ladder logic program is working, I'm not going to discuss this in this lecture because that was already discussed during the theory class. Here I am only going to show how to draw this fairy diagram in the software. So I can go to the HG5000 software. So this is the interface of the software. So in order to create a new project, I can click here the option called project and select the new project option. So after selecting the new project option, I'll have this pop-up window where I have to give a name to the project. So I can write to be traffic light sequence. So after writing the project name, I can select the directory where I want to save the project. Then I need to select the CPU type, the CPU series, then the CPU type. So I have been telling you that the CPU or the PLC that we have, it's from XGB series of the LS brand. So different CPU series is available here. So as our PLC is of XGB series, I have to select this. And then the CPU type basically depends on which model we have, and based on that, based on the model number, the one which is similar to the available models or CPU type here, we have to select that one for a particular board. Now the programming format is selected to be ladder diagram programming, and the program name can be given. Let's say I can give the program name to be traffic over here. So you can give the program name as per your desire, and if you want to insert any additional description of any project, you can write the description here. So after giving this initializing information, you can press OK to initialize the new project. Now after initializing the new project, we will get access to the editor window where we can place the different contacts and coils and insert different functions as per our requirement. So on the top, we have different tools available to us. Here we have the different contacts and coils and functions associated in the toolbar. We can select the one necessary for our operation, and we can place the particular contacts or coils or component in this editor window in order to draw the ladder diagram. So let's say if we want to implement this particular ladder diagram, then we first of all need a normally closed contact with address P00. So I can take a normally closed contact from here in the toolbar. So here is the symbol of a normally closed contact. I can select it and place the normally closed contact in any location in the editor as per our requirement. So I'm going to place it over here. So when I click on this particular block of the editor, then it will ask for me to insert the device address. So the device address is P00. So once I write the device address, then I can press OK. So the device has been initialized. So after this normally close contact, we need a normally open contact with the address P01, which is basically our starting button, starting push button, or momentary button. So we have to insert a normally open contact with address P01. So I can take a normally open contact and place it over here. So the address name I will give it to be P01. So this is for the start button, and in order to make connection with this particular contact, I can use vertical lines and horizontal lines. So I'm going to use a vertical line here and a horizontal line to make the connection. Then along with this, in this portion of the diagram, as shown over here, I have to place another normally open contact and another normally closed contact. So this normally open contact is basically associated with this output coil of P42, and this normally closed contact is associated with timer T01. So let me take a normally open contact and normally closed contact and place them in series with their specific addresses. So first of all, let me take a normally open contact and placing it in this block and typing the address P42, then taking a normally closed contact and placing it in this block with the address T01. After doing this, I can draw a vertical line to establish the connection between P01 and this branch, and lastly I can put another normally open contact in parallel with these two branches, that is having an address of T03, which is the address of timer T03. So I am taking another normally open contact here with address T03 and making the connection using this horizontal line. So this is the input side of the first line of the instruction, where three branches are connected in parallel, and on the output side we have to connect two output coils in parallel with address P42 and P43. So the output coil is basically here, the coil symbol that we have. The shortcut is F9. You can also use the shortcut to insert or go to the coil mode. So when I select the coil mode, then I can bring my cursor on the right hand side of this diagram and place an output coil with its corresponding address. So the address is P42, and in parallel with this output coil, I have to place another one with address P43. So I'm drawing a vertical line first, then I'm selecting the output coil and I'm going to place it in parallel with P42. Now here I have placed a vertical line, but I haven't completed the connection. That is why on the left hand side here you can see that the red color is basically indicating that there are some error in the connection. So the error here is that I haven't completed the connection. So when I complete the connection with the vertical line, you can see that that error signal will be erased. So this is basically the first instruction of this particular ladder diagram. Then in the second line, with the address of P42, I have to initialize a timer. with address T00 and a preset value of 300. So I'm drawing a vertical line again, and after drawing the vertical line, I am taking a normally open contact with address P42, and on the output side I'm going to take a timer function. So timer counters, this type of special functions are basically taken from this option here, which is called function, having a shortcut F10. So when I select this function, then I have to move my cursor on the output side where I want to place the function. So I want to place it here. So let me click over here. Now it will ask for me the instruction of the function that I want to insert here. So I basically want to insert an on delay timer. So I'm going to write T on. So here the software is also suggesting what is the format that I need to follow to insert this instruction. So I have already written the timer type, then I have to give a space, then write the timer address, then I have to give a space and then write the preset value. So here after T on, I'm giving a space, writing T00, then giving another space and writing 300, which is my preset value here to generate the 30-second delay. So now let me press OK. So the timer function has been inserted into the ladder diagram along with address P42 of the output coil. So when this output coil is getting operated, at the same time this timer operation will be initiated. So the process that I have shown up to this, I can follow the same process to complete the rest of the diagram that is shown in this particular slide. So let me do that, and then we'll try to simulate and check the how the outputs are going to change sequentially. So here I have completed the connection that was shown in this slide. So according to this slide, I have given all the connections. Now I have to insert an end function at the very end. So again, I can go to this option called function, and I have to insert the end block here. So let me click over here, and here in the instruction text box, I can write end and select the end function. So now my entire diagram is completed. So now I can try to simulate it in order to check the output. Now before I simulate it, I can discuss a few more things. That is, once I draw a particular diagram or a user draws a particular diagram, then if the user wants to write this ladder diagram program into the PLC board, then first of all what the user needs to do is to select this option called online. After selecting this option, the user has to select this option called connect. So if any PLC board is connected with the PC through some communication link, then the user can establish the connection with the PLC board by clicking on this option. Now you can see that the right option is disabled currently. And once the connection is established with the PLC, then this option of read or write will be enabled, and you can write the program into the PLC board. So that is the process of writing the program into the PLC board. Now, at this moment, if we want to simulate the program, then we can select this option here, the start or stop simulator button that is present in this toolbar. We can start the simulator by clicking on it. So I'm clicking on the simulator. So that's okay. So this is the simulation mode. So because before I run the simulation, let me do one thing. Let me modify the time constants. So instead of 30 seconds, let me uh, give set it to 10 seconds so that we can quickly observe the output pattern. Let me go back to the simulation mode again. So this is the simulation mode. Now here all the devices are in their initial state. So somehow we need to provide or start the process, provide an input signal to start the process. So we don't have any external PLC board connected at this moment from where we can send the signal at port P01 to start the process. So what we can do using the software, we can manually give the signal or change the status of this input uh, contact P01. So I can double click on this contact. So it is giving me the option to either set it to 1 or set it to 0. So it was already set to 0 as it was normally open. So let me set it to 1. So now it is normally closed. The timer has started counting. Now if it is a momentary switch, its state will change. So after 10-second count, the yellow lights has also glowed with our and after this 5-second delay, the other two pair of lights are now glowing. So after this 10-second delay again, we are going to get a jump to step 1. Sorry, before step 1, the yellow lights were glowing for 5 more seconds. So now we are at step 1 for 10 seconds. After this 10-second delay, yellow lights will glow for 5 seconds. So after these 5 seconds, these 4 pair of lights are turned off, and these 2 pair of lights have turned on. So this process will basically gradually go on sequentially. Now, instead of 30 seconds, in these two timers, we have set 10 seconds so that we can observe the changes quickly. So this is how the operation is going to take place. And if someone wants to stop the process, this some external signal has to be provided at port P00, which is for stopping the process. Now here in the simulator, we can virtually change it from let's say initial position from initial normally closed state to normally open state. So when we are making it normally open, then what is happening, the entire circuit is basically disconnected from the left hand side power rail, and everything has got reset now. So now if the port P00 stops receiving any input signal, it will go back to its initial position, the contact P00, which was normally closed state. But until and unless someone again starts the process by pressing the momentary switch at port P01, the system will not start operating again. So this is the traffic light controlling sequence example that was discussed in your 3D class, and you can implement the ladder or draw the ladder diagram using the software in this manner and simulate to check whether you are having your desired operation or not. Now, similarly, the other examples that were shown in your theory class, you can also try to develop those diagrams using this software and try to simulate and check whether the diagram that you're drawing is correct or not. So let me stop the simulation mode now. After stopping the simulation mode, so basically, if you want to implement the next example, which was discussed in your theory class, so in the next example, you need counter function, then you need reset coils. So in the software, if you go to this option call function again, then you have to select on a particular location in your diagram where you want to insert the function. I'm just randomly clicking over here. So in order to insert an up counter, you can write CTU, then you have similar format as you initiated an on delay timer for your counter as well. You have similar format. So after writing CTU, the counter type, you can write the counter address, then you can write the counter preset value. I'm not going to insert it here in this diagram, so let me cancel it. And about the reset call, so this one is your reset call with the same output bar symbol with an R in between. So you can say use this reset call and place it just as you have placed, or we have placed an output coil over here. You can press the reset coil and set the address of the reset coil as per your requirement. So here in this example, you need to use two reset coils with addresses C00 and C01, and in this way you can also try to implement this particular diagram and check whether you get your desired operation or not. So this is basically a brief introduction to the software, and hopefully you can from this lecture you will have some basic idea about how to develop a ladder diagram using this particular software. Thank you.